this lesson from 7-6 Ground School Chick, we're going to talk about your aircraft's engine. But first, a quick reminder that if you find today's lesson helpful, go ahead and like and subscribe so you don't miss out on any future private pilot ground school lessons. Also, if you're ready to get step-by-step guidance and mentorship that makes you feel confident, proficient, and at home in the sky, get in-depth instruction and get signed off to take your FAA written exam by an airline ground school instructor, send me a message at chickswhoflyofficial@gmail.com to become a student online directly with me, or click the link in the description. This material will come up on your FAA written exam and the oral portion of your check ride, so let's dive in. Excessively high engine temperature, either in the air or on the ground, will cause loss of power, excessive oil consumption, and excessive wear on the internal engine. An engine is cooled, in part, by circulating oil through the system to reduce friction and absorb heat from internal engine parts. Some of the things that can cause engine oil and cylinder head temperatures to exceed their normal operating range are the following: operating with too much power, climbing too steeply with too low airspeed in hot weather, using fuel that has lower than specified octane rating, operating with too lean of a mixture, the oil level being too low. Excessively high engine temperatures can be reduced by reversing any of the previously mentioned conditions, by, for example, reducing power, climbing less steeply, using higher octane fuel, and enriching the mixture. Aircraft can be equipped with either fixed pitch or a constant speed propeller. The advantage of a constant speed propeller, also known as controllable pitch propeller, is that it allows the pilot to select the blade angle for the most efficient performance. A fixed pitch propeller design features fixed blade angles set by the manufacturer, which cannot be changed. Its advantages include lighter weight, they are more simple to operate, and the cost is less. A constant speed propeller is a controllable pitch propeller with pitch that is automatically varied in flight by a governor, maintaining constant RPM, despite varying air loads. Constant speed propeller airplanes have both throttles and propeller controls. The throttle controls power output, which is registered in the manifold pressure gauge. The propeller control regulates engine revolutions per minute, or RPMs, which are registered on the tachometer. To avoid overstressing cylinders, excessively high manifold pressure should not be used with low RPM settings. Engines can be carbureted or fuel injected. Carburetor-equipped engines are more susceptible to icing than fuel-injected engines. The concept behind float-type carburetors lies in utilizing the contrast in air pressure between the venturi and the air inlet to regulate fuel delivery to the engine. Fuel-injected engines do not have a carburetor. The first indication of carburetor ice on airplanes with fixed-pitch propellers and float-type carburetors is a loss of RPM. Carburetor ice is likely to form when outside temperature is between 20 degrees Fahrenheit and 70 degrees Fahrenheit, and there is high humidity. When carb heat is applied to eliminate carb ice in an airplane equipped with a fixed-pitch propeller, there will be a further drop in RPMs due to the less dense hot air entering the engine, followed by a gradual increase in RPM as the ice melts. Fuel-air mixture is the ratio between the mass of air and the mass of fuel, the mixture prepared for combustion at any given moment. Carburetor heat enriches the fuel-air mixture because the air is warm, and therefore less dense. The fuel-air mixture becomes richer since there is less air for the same amount of fuel. Applying carb heat decreases engine output and increases operating temperature. At higher altitudes, the fuel-air mixture must be leaned to decrease the fuel flow in order to compensate for the decreased air density to keep the fuel-air mixture constant. If you descend from higher altitudes to lower altitudes, without enriching the mixture will become leaner because the air is denser at lower altitudes. If you are running up your engine at a high-altitude airport, you may eliminate engine roughness by leaning the mixture. The definition of fuel-air mixture is the ratio between the weight of the fuel and the weight of air entering the cylinder. Another thing to look out for is detonation, which occurs when the fuel-air mixture explodes instead of burning evenly. Detonation is usually caused by using a lower than specified grade of aviation fuel or by excessive engine temperature. This causes many engine problems, including excessive wear and higher than normal operating temperatures. Lower the nose slightly if you suspect that an engine with a fixed pitch propeller is detonating during climb out or after takeoff. This will increase cooling and decrease the engine's workload. Our training aircraft usually have a dual ignition system. This is a system for spark ignition engines, where critical ignition components, like your spark plugs and magnetos, are duplicated. Some benefits of a dual ignition system include increased safety, reliability, more power, and even combustion. There are some other issues that you can experience with your aircraft engine. Some examples include loose or broken wires in the ignition that can cause problems. For example, if the ignition switch is off, the magneto may continue to fire if the ignition switch ground wire is disconnected. If this occurs, the only way to stop the engine is to move the mixture lever to the idle position, then have the system checked by a qualified aviation maintenance technician. A condition called pre-ignition is the uncontrolled firing of the fuel-air charge in advance of the normal spark ignition. Use of the next higher than specified grade of fuel is better than using the next lower than specified grade of fuel. This will prevent the possibility of detonation or running the engine too hot. Another thing you can do is fill the fuel tanks at the end of the day, because this prevents moisture condensation by eliminating the airspace in the tanks. All fuel strainer drains and fuel tank sumps should be drained before each flight to make sure there is no water in the fuel system. If an airplane is equipped with fuel pumps, the auxiliary electric fuel pump is used in the event the engine-driven fuel pump fails. Whenever you start your engine, the throttle should be adjusted for proper RPM. And the engine gauges, especially the oil pressure check. During cold weather operations, special attention is required when performing a pre-flight inspection. The crankcase breather lines may become clogged with ice. When the crankcase vapor cools, it may condense in the breather lines and subsequently freeze, causing a clogged condition. I hope today's lesson was helpful. If so, please like, subscribe, and hit the notification bell so you don't miss out on any future private pilot ground school lessons. And if you're interested in doing your private pilot ground school online directly with me and have me sign you off to take your FAA private pilot written exam, please reach out at chickswhoflyofficial@gmail.com.